This is Chapter 1, Introduction to Computers, Programs, and Java. And in this video, we're going to summarize what we've learned so far in Chapter 1. So we're going to start off with programming languages. So what is a programming language? Well, programming language by definition, it is a formal language which comprises a set of instructions used to produce various kinds of output. And formal language is a set of strings of symbols together with a set of rules that are specific to it. And one of the many programming languages out there is Java, which is what we're going to be learning. And Java is a general purpose computer programming language that is concurrent, class-based, and object-oriented. Now let's get a better understanding of what is a formal language, so we could get a better understanding of what is a programming language. Well, formal language is, like I said, a set of strings of symbols together with a set of rules that are specific to it. Now, in Java has many type of set of strings or symbols that it uses, and these set strings and symbols has specific meaning. And some of it, which is, for example, we're going to take a look at this example right here out of many type of symbols that Java has. This int right here is a type or a data type. And what is this int? Well, short for integer. And now this int right here, what does it do? It simply is letting Java know that this data type int could be used to create variables, and that variable will have a data type int or integer that could hold literal values such as 99, 12, or this extremely large integer number right here. Alright, so in Java it has a set of strings or symbols with a specific meaning, and it has many type of these. And another one in Java is the double data type. Now, this double data type, what it is a floating point number data type. And we could use this data type to create variables that hold floating point numbers, such as 3.14 or 2.5 or 6.0. And we could combine it with operators. But I don't want to get to go too far into that and start confusing you. So simply you just have to understand that Java could have many type of strings and symbols, and you could combine it with operators and other type of symbols, and you put it together and you could form a set of instructions used to create various type of outputs. Alright, now in Java there are three type of programming languages. One of them is machine language. So what is a machine language? Well, it is the computer's native language, and it's a set of built-in primitive instructions in the form of binary code. So simply put, machine language is something that only a machine could understand or a computer could understand, and it's made up of binary code. Now, binary code is just a bunch of ones and zeros. So that's all that the computer can understand, a bunch of ones and zeros. It doesn't understand anything more complex than that. Alright, so to get a better understanding of what that means, let's talk about the assembly language, which is the second type of programming language out there. Second type, right? And by definition, it is a short descriptive words used to represent specific machine language instructions. And for example, one of them is the add keyword in the assembly language. Right? Add in the machine language simply means to add two numbers together. For example, right here we have add 2, 3. And in assembly language, it knows to add 2 with 3 and to show the result 5. Now, a computer won't understand what an assembly language is. It will have to compile this assembly language and it'll break it down into a bunch of zeros and ones and then it will know what it means. So us, as the programmer, when we see this, we know what it means. But for a computer, it will have to break it down into ones and zeros, then it could do the work that you tell it to. But as a programmer, we're not going to be able to write a bunch of ones and zeros. It is just so easy to make a mistake, right? If we write one extra one or one extra zero and it's out of place, that'll break everything. And we won't even know where to go to fix that mistake that we just made, that 1 and 0, because it just looks all the same to us. Do we know what these 1s and 0 means? No, we don't. But the computer, when it looks through it, it does. So that's where it goes to what we're doing right now, the high-level language, which is what we're writing, right? Instructions written in a high-level language is called a statement. And that's where we'll be learning to write computer code in Java, right? Which is a high-level language. And we'll definitely be seeing more of these examples later on. But simply put, the three types of programming language out there is the machine language, assembly language, and finally high-level language. Of course, the computer can only understand one, the machine language. We, as a programmer, can understand all three, but it's just difficult to understand the machine language. It is not as difficult to understand the assembly language, but it's much easier for us to write in high-level language. And that's what Java is. So let's go into why we should learn Java, right? And for me, I wrote my top 3 reasons on why you, the viewers, should learn Java as a programmer, as a developer. Why use this language? Of course, there's many other good reasons out there, but I just want to point out my top 3. So let's start with the first one, right? Java is object-oriented. And what is object-oriented and why is it so good? Well, for that part, if you don't know what object-oriented is, we'll be going to that a little later on. But by learning Java and by understanding the object-oriented concept, right, we will be learning object-oriented design principles, which is really good to use, really good practice as a developer. We'll be also learning conventions of a good programmer. And these conventions as a good programmer is by learning or by being able to understand how to write good code that makes it more reusable, makes it more maintainable, and makes your code, or by writing codes that are properly encapsulated. All right, you will learn all of these, and these will make you a good programmer. Number 2, Java is platform independent. Now, if you haven't heard, Java's tagline is write once, run anywhere. And you can see Java apps everywhere, from Windows to Androids to your microwave. So what does that mean, write once, run anywhere? Well, Java is a language that you could really, you could just write, and as long as there's a JRE on that machine or on maybe your digital clock, there's a JRE, you could write your program and you could just make that digital clock run or do whatever you write in that program. All right, it's super strong, it's really powerful, but it's so simple and so easy to move from one thing to another when you're writing your program. Example, many of you probably running Java program nowadays, and you probably don't even realize it, especially in your Android phone if you're using an Android phone. Or if you're not using an Android phone, you could be using practically almost anything else from your smart TV. You could be running a Java application, right? Java is basically used almost everywhere. And finally, one of the top most important reason for me as a Java developer and why I love to learn Java is that Java has an excellent community. There's an amazing community out there that's always out there to help you with Java. There are sites like Stack Overflow and Reddit that has many smart and helpful people that would love to share their knowledge of Java with you if you ever need help. These communities are big, they're smart, and they're wonderful, and they just comprise of these awesome people that are always ready to help you if you have any questions, or you're confused, if you're stuck. Just jump onto these communities and ask your questions, and you'll definitely be able to receive helpful advice, tips, hints, and guidance. All right. Now, back onto topic, words you should know in Java. Now, as we're going through the chapter, right, as we're trying to summarize the chapter, there's many keywords in this chapter that are used and that you should really pay attention to. But one of the top 4 that I noticed that pop up a lot that early or beginner programmers should really review and remember are these specific keywords right here, because they're going to be used a lot. And if you don't understand what it means, it will really confuse you as you continue to learn. So the first one right here is the word compiler. Now earlier we used the word compiler or in one of our slides, but before I jump to that, I want to read the definition I have here, right? So a Java compiler will read your high-level language and converts it to bytecode or simpler set of instructions for your computer to execute. Now, why does that sound so familiar? Well, when we were talking about the 3 types of programming languages, I used the keyword compile before, right? Or if I haven't, well, let me use it now. Right? When you're writing your high-level language, right? So when you're writing Java and when you're compiling it, how does your computer know these keywords? How does it know what to do with these keywords? When we're breaking it down, the computer really doesn't know what that keyword, what that int or other variables or classes or objects, it doesn't know what that means. It takes your Java statement and it breaks it down. It compiles your Java statement, your class file, and it turns it into a bunch of zeros and ones. And then it reads those zeros and ones, and then it understands what to do. All right. So you're going to be using the Java compile a lot. You're going to be compiling your code, and it's going to, this Java compiler is going to take your code, and it's going to break it down, and it's going to allow your computer to understand it. It's going to break it down to binary codes, and it's going to read it, and it's going to run those set of instructions you told it to do. All right. So that's what a compiler is. All right. The next thing is variables. So what is a variable? Well, a Java variable is a name, right? A name of a piece of data. So sometimes a lot of people get confused. What is a variable? What does it do? How do I use it? How do I create it? Well, just as long as you remember, a Java variable is just simply a name of a piece of data. And the variable holds a piece of the computer memory which will be used to store the data. So here's my example. Can you tell which one of these is the variable, is the Java variable? All right. Now, if you remember this word right here, this keyword earlier, from when we mentioned earlier in our second slide, I said in Java there are keywords. One of those keywords is this int keyword, which is short for integer. So Java knows that this int keyword is a data type, and the data type is an integer data type, and it says that this int will make sure that this right here will hold some kind of integer value. And then we see it equals 10. So we know, okay, this int makes this string right here equal to 10. So basically it's assigning this 10 right here to this string right here. So what is this string, this number right here? Well, there's no keyword in Java called number. What this is a variable. it is a name of a piece of data. So what is going on right here, there's quite a few things going on. Java is grabbing a piece of data in your computer, and in that piece of data, in that memory location, is storing this value 10. It knows that this value 10 is an integer, not a decimal, or not a string, not a character. It is an integer, because right here we state that it's an integer. And to be able to access this integer, we have a variable right here. This variable equals 10. So when we call this variable right here, we will be able to grab this value 10. Now all of this might seem pretty confusing, or you have no idea, even though, or it just doesn't make sense. Don't worry, we'll be doing quite a few programming exercises where we'll be creating our own variables, and when we're doing that, you'll get a much better understanding. All right. So for now, if you don't understand what it means, just understand the definition, and we'll be going back to it later. And we'll just review that definition, and we'll take it into practice, and it'll be much easier then to really understand what is a variable. Now, third, we have operators. Once again, in the second slide, we saw operators. We saw these plus, minus, divide, multiply, module, this plus sign, this minus symbol. In Java, all of these have a meaning. It knows that these operators, or this plus sign, minus sign, divide sign, has a meaning. It knows what it does. So that's what makes a programming language a formal language. It takes these symbols and it gives it meaning. And for Java, it knows what it means. All right. So understand that in Java, we have things called operators, and we use these operators to perform arithmetic operations. And then lastly, we have statements. All right, statement, as we mentioned earlier, we're going to be writing a lot of Java statements. And simply what it means is, in Java, a statement is a set of instructions or command. And there are two types of statements. There are expression statements, which is made up of variables, operators, and method invocations. And then there are declaration statements, which simply declares a variable. So right now, if you haven't noticed, we actually written a statement right here. So which statement is this? Is it an expression statement or declaration statement? All right. Right here we have an int data type with a variable called number, and we have assigned 10 as that variable's data type. So right here, this is actually a declaration statement. We have declare a variable. We're declaring that this variable is equal to 10. All right. So we have just written a statement, which is a set of instruction or command. So this is actually an instruction right here. All right. So that is a statement, but we're going to be writing many more statements. So if you don't understand what this means now, no problem, don't worry. There'll be more examples later on in programming exercises. So the next thing we're going to be moving to is basic Java conventions, writing comments. Now, comment is important. One of the things is why it's important is because you're going to always be told to always comment your code. And you can document your code. Always document your code. You can document your code by writing comments. This is going to be important for the rest of your programming career if you choose to move forward, and it's super easy to learn. But we don't want to go too in depth into it, because once again, this right here is just thrown in front of you, this bunch of sentence right here. And we're not going to know what that means. We're just going to read it, but don't really understand it. So for now, I'll just briefly go through it, and we will be using or writing up comments in our exercise. So just remember that there are three types of comments. There are line comments, which you could write, which comment out a line. So if you don't have much to write and just want to specify one statement, one piece of code, then you could just write the line comment, which is just 2 forward slashes, and everything after 2 forward slashes is your comments. And good thing to know, to understand, is that these forward slashes let your compiler, right, once again this keyword, right, a compiler, know to ignore all characters past the 2 forward slashes for the rest of the line, right? No mistake right there. So once again, we have a compiler right here. Just in case you're interested and you want to know what this means that when the compiler, when it breaks down your code into a lower level language, the machine language, breaks it into a bunch of zeros and ones, it's going to be able to understand that, oh, you ran a statement right here, but then you wrote 2 comments, 2 forward slash, and everything after forward slash is not code. It's just something for you, the programming, to understand, and not for the computer to do. All right, and then there's block comments, which block out multiple lines. So if you don't want to just write comments on one line and you want to write comments on multiple lines, you will write block comments. And then lastly, one of the most important thing as a developer is to understand is to write java.comments. And why java.comments is so important? Well, it's because it's used to generate documentation in HTML format. And you're going to be doing this a lot. So that's why I want to throw this out there, because even though this is something really basic, but this is a Java convention that you should always be practicing. All right. But we'll be moving on and we'll be learning about that later on. Now, another convention that I really want to point out, that I really want to throw out, that you should really practice and really get used to doing, something really simple that a lot of beginner programmers don't really do and end up writing really sloppy looking messy code, is that they don't space out properly. If you want to write good clean code visually, you should always indent and space. Always indent your code. Convention states that 4 spaces to be used or 8 spaces for a tab when tabbing. This will allow programmers to read your code and allow you to convey a better structure for your program. This will make it easier to read and maintain the code. All right. So just keep that in the back of your mind. If you're already programming, you're already starting out, and you know what I mean, then awesome, right? Indent and space. If not, don't worry. Once again, when we're doing our programming exercise, I will be using these conventions. And of course, beside indentation, good indentation is spacing out your operators and variables. Once again, that keyword operator, that keyword variables, you can be seeing it a lot. Now, when I say spacing, what do I mean? Well, for example, right here, this bad thing to do is clump up this number right here, this integer, with this operator. This plus sign is an operator, right? This 2, this minus operator, this 3, this multiplication operator, and this 4. And right here, this is actually a statement. What kind of statement this is? Well, this time we're not declaring a variable. So this is actually an expression statement, all right? And this expression statement is made of variables, operators, and method invocations, where we see a whole bunch of operators right here. The good thing to do, the proper thing to do, is properly space out the numbers and the operators right here. That way we could really see what's going on. It's much clearer to us, the programmer, all right? And much clearer to other people who's going to be reading your code. So make sure to space out your code. And the next thing right here is one of those few things that we should really practice is block styles. Now, there are 2 types of block styles out there, and and this kind of style isn't really like make or break. It really doesn't make or break you as a programmer or developer, but different companies prefer different styles when writing their code, and it's really good to understand what kind of styles that company will be using. That way, when you when you join that company and you jump into the team, you want to be able to really be able to understand or write code that are similar in their style. So that way you won't really mess up their format that they're going with, right? Simply put, the two type of block style is end of line style and the next line style. Now, once again, whatever you do, it doesn't really change how your code runs. It just changes how it looks. And like I said, the way it looks is important. You want to be organized. If you're going to write something one way, you should always keep it like that way for the rest of your program. So end of line style basically means you have your braces right here, which is within, there's two braces, and actually I should say what these braces do. Well, we should know about what is a block. A block is a group of statements surrounded by braces. All right, so where we have these braces right here, the end of line style just states that you start your braces at the start of the line, at your start of your line of code right here, and then you end it when after your next line of code. All right, that's kind of, I'm not so good about explaining braces. It's more of a visual thing, right? And then next of line style is you start your braces after where you start your first line of code. For now, let's just say I'm going for my program exercise, I'm going to be using end of line style. That's what I'm going to be going with. But depending on, it really doesn't matter what kind of style you choose when you're writing code for yourself. All it really matters is when you join a company, you should really follow, you have to follow their style. All right. But let's review what a block is. So a block is basically a group of statements surrounded by braces. So right here, this is a block of code. If you have multiple lines of code and then you just surround that line of code with braces, we'll just keep that kind of a visual in our head for now. And we'll move on to learning about programming errors. And this is one of the things that I really wanted to jump and talk about, and that's mainly because as a beginner Java developer, one of the main things that most of beginning Java developers, one of the mistakes that they tend to do or write, I should say, when they're writing their code and they're making mistakes, they're not understanding what kind of mistakes they're making. And this really makes the developer, the programmer, the person that's learning to program, it really crushes them because they're lost and they have no idea what kind of mistakes they made and how to fix it or where to look for it. So by understanding the type of programming errors out there, it will better help you to better resolve your issue, to know where to look, to understand what kind of errors it is. And if you understand what kind of error it is, you will understand how to solve that error. So that's why we will review the 3 types of errors in Java. Now the first one is known as the syntax error. Now what is a syntax error? Well, like name says, is the way you write certain things. So by definition, this occurs most, or actually this type of error occurs most when the programmer misspelled a keyword, omitted some necessary punctuations, or missing adding a braces. So that's the syntax error. If you, for example, earlier we saw the keyword int, right? This keyword int here, instead of writing int, you wrote it, you wrote in, you wrote IT, well, the computer don't know what those words are. It knows specific words. It knows this int keyword. So if you write it, that is a syntax error. And Java does not know what that means. And when you try to compile your code, it will say, hey, here's an error. You wrote it, but I don't know what it is. I know what int is. So you go back to it and you'll be like, okay, I see what I did wrong. Change that up and you fix your issue. Change that it or in and turn it back to an int and it'll work again. All right. So our next type of error is the runtime error. Now the runtime error is a little bit more tricky. This type of error is when you're trying to get the program to do something impossible and cause the program to fail. For example, one runtime error is that in Java, you cannot divide any numbers by 0. So if you try to do that, you're going to get an error and it's going to say it's a runtime error. So runtime error is basically when Java is compiling your code and it's trying to run the instructions you give it, right? So actually, no, sorry, it finished compiling your code and now it's trying to do the instructions. Now it's trying to do the work. But then while it's trying to do the work, it encountered a problem. It encountered the problem that you're trying to tell it to do that is not possible. And for example, if you're trying to divide by 0, Java will be like, hey, I can't do this. I don't know how to divide by 0. That's not possible. So that is a runtime error. All right. So then you will have to go into your code and you will have to find out where in my code is giving this issue that is causing the compiler to say, I can't do this. All right. So that will sometimes get a little more trickier to resolve. All right. And lastly, we have the logic error. Logic error, this error cannot be caught by a compiler, right? So when you run your code, Java will compile your code and then it will try to do the work for you. You will say, hey, right? Actually, let's read this, right? It's the error cannot be caught by the compiler. It is all on the programmer. Let's say when you're trying to convert Fahrenheit to Celsius, but you did not write the formula correctly. You keep ending up getting the wrong results, and that is a logic error due to a lack of due diligence when checking if the formula was correct or not. All right, so you could write code that is not syntax error, right? There's no mistakes in writing any kind of or in spelling. There's no runtime error where you're trying to do something that's impossible in Java. But you as a developer is making the mistake of entering the incorrect formula and then the output ends up being wrong. And you look at it and you're like, hey, it's wrong, but where is it wrong? Well, that is a logic error. You go back into your code and you try to figure out where did I enter that formula or that instruction that I did incorrectly. So that you will have to figure out yourself. All right. And then we'll begin to wrap this up with beginner's tip on errors, right? So when I start to learn programming, I make these errors all the time. And these were just simple errors that is so obvious that sometimes I think to myself, how did I make these mistakes? All right. So mistakes such as missing braces, which is simply you cannot write your code without it being inside the braces. You have to have your code inside the braces for the code to run, right? So all statements, which is Java instructions, should be wrapped in braces. Most beginners forget to add a closing braces, right? This one right here. So it's wrapped between two parentheses to really specify what I'm trying to write at the end of their statement. So they'll know to start with a braces, right? A brace. And then they write out their code, but then they forgot to close it up. So that's what you gotta do. And then there's the missing semicolon, all right? So all statements, which is Java instructions once again, all statements must end with a semicolon, right? You cannot be making this mistake. This is the most simple thing to do. You write your code and you close it up with a semicolon. And the semicolon let Java compiler know that this is the end of the line for this code, and to start the next line as a separate set of instruction. Missing quotation mark. This is known as the double quotes, and this is known as a single quote in Java. They both have separate functionalities, but for now, know that another common mistake is that the user tend to forget to finish writing their strings or characters by ending it with a double quote or a single quote. All right. When writing a string, it has to be in quotes. And then lastly, misspelling names. Writing main instead of main, right? Java is case sensitive. So you can have multiple strings called main, but it can all be written differently since upcasing one character makes it unique from the other main strings. So sometimes you're writing a variable and you're naming it differently, and then as you're writing it, as you're going further into your code, you forgot how that variable is spelled. You made it unique. You wrote one uppercase, one lowercase, and the rest as a mix of uppercase and lowercase. Now, when you're trying to use this variable, that exact variable, it has to be exactly the same way you spelled it originally. It has to be, the uppercase and lowercase have to be, for those characters have to remain the same. If you don't, you're creating a whole new variable, you're accessing a whole different variable, or you're accessing a variable that does not exist, because Java is case sensitive. All right, and lastly, a few tidbits to end this chapter with that that is more of a good to know, and a good way to really end this chapter with summarizing what we've learned so far. So I'm just going to go through it, right? So in computer programs, also known as software, which are the invisible instructions that control the hardware and makes it perform tasks. Computer programming is the writing of instructions for computers to perform. So we're writing all these statements, they're just simply instructions. If you're writing in Java, you're writing in high-level language, the Java compiler will break these high-level language down into smaller a simpler instruction for the computer, which is the machine language, because the computer can only understand binary codes, a bunch of zeros and ones. And then the computer will read these zeros and ones and perform the type of instructions that you told it to do. This right here is known as code, or if you're writing it, coding. The central processing unit, the CPU, is a computer's brain. It retrieves instructions from memory and executes them. A bit is a binary digit, or 0, 1. So if I'm talking about a bit, it's 1, 0, 1, 1. All right. Multiple bits means multiple zeros and 1. A byte is a sequence of 8 bits. So if I'm saying, hey, there's a give me a byte of data, so it's just 8 zeros and 1s. Memory stores data and program instructions for the CPU to execute. So like I mentioned earlier, if you still remember, right? We're declaring a variable. Java will grab a little bit of memory, so that way when you state that a variable is of int type and stores 10 as that value, it'll go into that computer memory and it'll grab that memory and say, in that memory, it'll remember to say that variable is equals to 10. Right, and memory is volatile because information is lost when the power is turned off. So in your memory, the memory is super fast, but it's volatile. It's forgotten. It's not, when it's not used, it's gone. Programs and data are permanently stored on storage devices and are moved to memory when the computer actually uses them. So right now you have stuff stored on your computer. You have software. You have, for example, the most commonly used is Microsoft Word, right? That is a program that's stored on a permanent storage device that remembers that it's there. So that's different from the memory, where it only remembers it for a short period of time. And lastly, let's end this with reserved keywords. Reserved words or keywords, such as reserved words or keywords have a specific meaning to the compiler and cannot be used for other purposes in the program. And we're going to jump back into that int keyword. Int is used by Java, right? It's taken by the Java compiler. So if you want to use this specific keyword right here, all lowercase int, you cannot, because Java is because that keyword belongs to Java, and Java knows what that keyword means and what it does. So if you try to write it up, it will just go straight to that definition written by Java or in Java. Alright, so that is it for this video. Hopefully the summary of this chapter makes sense. And after this video, we will be jumping into writing programming exercises.